do kind of all manner of software, consulting services, and stuffs. Basically, what we've been doing a lot of is helping people modernize their practices. We kind of work in the government sector and the defense sector, and a lot of their software development practices just suck across the board for a variety of reasons. It's not really a person problem so much as it's kind of an institutional problem. But so we jump in and we say, hey, we know how to do things. Let us help you do things in a better way. So that's kind of what we're up to. As I say, we're in the Dayton, Ohio area. We're hiring. Let me know if you're interested. We can chat after. And so this talk is going to focus on kind of categories of tools. So if you read the tagline for this talk, I said this talk is for everybody. And so that means I can't go too low and I can't go too high. I'm trying to find a Goldilocks zone. But the reason I'm targeting the Goldilocks zone is because security is not an isolated thing that we can just go get and acquire and bolt onto an application. It kind of requires stakeholders and developers and acquisition people and the ops people who are going to push stuff out. And one of the reasons that we're not getting the security that we want and need is because we're all talking different languages. So that's what I'm hoping to address. So with that in mind, bear with me if this is painfully obvious to you, but in an organization, it's not painfully obvious to everyone, right? So sometimes it helps to go simple. So what is AppSec? Well, AppSec is application security. And if you don't know what an application is, it just means software. That's software security. And so then AppSec is all that stuff that you do to improve the security of an application during development. I'm making that distinction. That's my personal definition. AppSec is during development, and that's a way to differentiate it when I'm talking to IT people about ops concerns and infrastructure concerns from everything else. So, configuration and deployment, they're really important too, but I'm not going to talk about them for the purpose of this talk. And as I mentioned, being specific is really important because when you have different stakeholders in the room, especially non-tech people, they have no idea what we're talking about. If you are a security person hanging around other security people, you are in a bubble. And as soon as you get out of your bubble, everyone is immediately confused about what you're talking about. And so having a small subset of definitions that you use consistently across people that you're interacting with, I found to be immensely helpful. So, as an example, there are people who don't understand that a software can be vulnerable separate from how an infrastructure can be vulnerable. They would say, well, why do I have to worry about software security? My systems are patched, right? They're patched, they're up to date, we're monitoring them, we're logging them. What's the issue? And they just fundamentally, it's black magic inside the box. And that's not their fault, right? But as security professionals, we've got to help them understand those differences so that they can put the right focus in the right places. But if you've not worked with people outside of the tech bubble, the level of comprehension really is that low of failing to differentiate between what's an app and what's my infrastructure. What's my IT team responsible for versus what is my software development team responsible for? So setting the baseline is critical. Okay, so then since we've defined AppSec, I guess I also have to define what secure means. And so I'm going to use the tried and true CIA triad. Again, what I like about this is that it's small and it's concise and it's explainable in a conversation to somebody who may never have encountered it before. It gives them something tangible to actually kind of think about, because the word security and the word cyber kind of doesn't really mean anything unless we define it. So for the purposes of this talk, secure means CIA triad. C for confidentiality, your secrets stay secret. I for integrity, your thing works the way you want it to, your data doesn't get corrupted. And A for availability, it's there when you need it. If an attacker or something else would deny you any of those things, you would lose security. You would lose your CIA. You wouldn't be able to do what you want to do when you want to do it. And then why even have the software at all? So this is a good enough framework to kind of facilitate conversations. Again, remember, not everyone's a software developer. So I work with people who are IT people, who are information assurance people, and they're not all software developers. Even tech people that we work with on a daily basis fail to appreciate some of the stages of the life cycle of software development, right? So just briefly, from the high level in 30 seconds, someone writes a requirement. That's them saying, hey, I need a thing to do a thing. You hand that over the wall to an engineering team, and they start designing it. They decompose that requirement. They figure out how they're actually going to achieve that thing. Then they begin developing it. Development looks something like source code, which is just text files, get pushed into a piece of software called a linker. And a little bit of this is language specific and ecosystem specific. So just generally, a linker says, hey, you called out some other code that you didn't write, but I know you want to use and beg and borrow and steal, so I'll pull that in for you. This is you importing other people's code. Then you've got a compiler or an interpreter, and that's the piece of software that turns your text files, your source code, into the actual application. Then you test it. If you have the time and money, you do this in a loop. You can do this incrementally, right? But as I say, I kind of come from the government side of the house where they tend to do things in big bang development, waterfall development fashion, because that's how they're used to doing acquisition. And so that's kind of a fundamental problem, that the acquisition cycles are just not aligned for software acquisition. They're getting better, but they're not there yet. It's just not how people think at this point, still. Then you test it, then you deliver it, then somebody's got to configure it and actually deploy it on an endpoint to provide value to people, and then you're into runtime, and runtime monitoring and management. If you follow the security space, of course, you guys know that like SaaS is hot, and so there's lots of time and money and tools focused at SaaS, but while SaaS gets a lot of press, the rest of the world still operates with things on individual endpoints, maybe air-gapped, maybe in enclaves. I'm talking about your IoT things, your city infrastructure things, pretty much anything on a hard box that's not designed to be like a subscription service is kind of the traditional deployment model. And there's nothing wrong with that deployment model, but again, a lot of the literature and news that you see lately about security really focuses heavy on that end time. Like hook your SaaS app up to our monitoring app so you can get a dashboard and emails all the time, blah, 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 blah. That's great if you live in that environment, but if not, you need something else. So let's talk about the something else. So we know what applications are, we know what security is, we kind of understand how software is developed. So then the real question is, why are applications still so insecure? Obviously, this is not a new topic, right? And there's plenty of information available, blogs, tools, books, conferences, like we're at right now, right? Which means people care, I care, I'm here, you care, you're here. So then why are applications still so insecure? What is happening? Well, I think it's fundamentally this. If you don't ask for it, you don't get it, okay? So the GAO, the Government Accountability Office, they study stuff like this, and they produce reports and recommendations. And so they studied, why does government software suck? And their primary conclusion was, from this report, it's not in the contract, right? If you don't put it in the contract, no one is going to give it to you. Think about how a software engineering firm works, right? They've got to maximize profit. So there's that delta between the cost it takes to build the thing and the price at which you sell it, and that's your profit. And so no one's going to add requirements. Nobody's going to say, I know you care about security, but you didn't ask for security, so I'm just going to give it to you on the side. That eats into profit. No, they design to the requirements. They design to what you ask for. So if you don't ask for it, you don't get it. This is why communication across functional domains is so important, why we need to educate the people around us. Because we want to get rid of those unknown unknowns for them and turn them into known unknowns. They can say, I don't understand how software security works, but I know I want it, and I know I need to ask for it. Okay? So the AppSec problem kind of starts at the beginning of the acquisition process then, and it just ripples all the way through the end. Not because anyone's malicious, not because anyone is not capable of doing the job. It's just not a focus area. It just doesn't enter the conversation. So then this is the summary of the problem, right? The people who request software don't know how to ask for security, so they don't write any security requirements. Then the people who are building the software, since they have no security requirements, they don't actually put anything in. Also, they probably don't have any AppSec training. If you work with developers, go ask them how many of them had a credit hour in college dedicated to security, right? Yeah, 0, I see it. I know, because I was one of those people who's like, I'm gonna take every elective I can, and there was one. There's one elective, not in the core track. You had to go out of your way to get the security course. And of course, it's not just AppSec, it's like, it's very CS-y, like let's write our implementation of AES. And it's like, okay, that doesn't fix my build, right? That's interesting theory. That's not application security, right? It's the science and not the engineering. So there's a gap there in training. But as I said, the information's available if we only would go get it. And then meanwhile, it's just to dump on IT, because that's what happens, right? Everyone else just assumes IT is handling it, because they don't understand that separation of concern between what's ops, what's infrastructure, what's software. it gets thrown over the wall to IT, and they say, put this on our server so customers can touch it, and then everyone assumes that IT just knows how it works and how to configure it, and that they can like magically open the hood and fix things if it's wrong. Well, newsflash, a lot of your IT people aren't software developers, and that's not fair, right? That's totally not fair to put that extra burden on them when they've never been trained for it or scoped for it. So again, we need to educate the people around us. Non-tech people don't understand our various swim lanes. Even inside the computer sphere, inside the cyber sphere, you've got compliance people, you've got information assurance people, you've got your IT network admin types, you've got application types. So, and even we aren't all speaking the same language. Clear communication is key. And so that's why I said this talk is for everyone, because it's going to take all of us to kind of dig ourselves out of the hole. We've got the requesters of software. I'm going to use these terms. They're slightly inelegant, but bear with me. There's the requester of software. That's the person who says, I need a widget. I need a software widget that does a thing. There's the developer or the team of developers. And then there's the evaluator. And the evaluator may be the requester who's evaluating the deliverable that they've received. It may be an IT person who's deciding whether or not this thing goes on the network. It may be a consultant like myself. This is how I use the tool when I show up and I say, how good is your process? So that's why this talk is for everybody, because we're going to try to hit that Goldilocks zone. And the goal is to establish this common baseline of what good enough means for application security. And unfortunately, we're going to have to talk about a little bit of AppSec jargon. And we're going to do that because those are the proper names, the technical names that you'll see if you're reading this space. But caveat that jargon is an impediment to understanding. And so if someone else speaks your jargon, great, you can have a high-speed conversation. But if they don't speak your jargon, don't make them speak your jargon. If you want to be an effective communicator, you've got to meet people where they are, right? So great example, source code scanning. People are generally familiar with this thing, but it's got this cool high-speed definition called SAST. So when you go talk to your program manager or somebody, your acquisition person or whoever, don't say, we got to have SAST, we got to have SAST. They have no idea what you're talking about. And when they say code scanning, don't correct them. Don't spank them and say, no, it's called SAST. The intent is there, right? We want to build allies, right? Not shoo people away. So call it source code scanning, call it a code scanner, call it a linter, call it whatever. It doesn't matter. It's the objective is the more important part. So don't browbeat people for using inelegant terms. But we'll use them here just to level set us. So great, we need a common baseline. Who gets to decide what that common baseline is? Well, so here's my journey. Here's what happened to me. I got airdropped into a developer environment. I had changed jobs. I was previously kind of a vulnerability researcher, and so I was used to looking at closed box, no source code, reverse engineering, decompiling kind of stuff. And then I get dropped into kind of a modern dev ecosystem where not only do they not speak my language and they don't have any security training, I'm not familiar with their, I'm generally familiar with their workflows, but not their specific workflows. And so I've got to go out and kind of come up with a plan for how I'm going to improve their ecosystem. And so this was last year, actually. So I read all the papers and reports I could find. I was reading books. I was watching YouTube videos, old con talks, all kinds of stuff, and trying to find what those industry best practices were. Because again, the press releases you see are usually like tool specific, right? New tool, it's great, it's awesome, use it. Like, okay, great, but the problem's bigger than any one tool. Right? I kind of need a little bit of a methodology. I need a little bit of a plan, something that's repeatable. And so right as I was kind of coalescing on what I thought that was, the government did something kind of neat. They came out with the NIST minimum standards. Go to that website, that URL, you can find the NIST minimum standards. So what is NIST? NIST is the National Institute of Science and Technology. They are a government organization that produces various standards. If you've encountered them before, it's probably for something like IT security compliance. So a good example of that is NIST 800-171, which is a list of 100 plus configuration items that you're supposed to set to make your system secure, to host government information. If you have a contract or something like that, it's considered kind of a good enough baseline for protecting information. The problem is it's completely incomprehensible, right? Try to read that document. Try to make sense of it. Try to make it actionable. It's hard, right? And so if you're parachuting into an environment where you need to stand up something quickly, not only is it the wrong tool, but it's not even, to people who know what they're talking about, it's hard to kind of wrap your head around. So NIST made this thing called the minimum standards, which is focused specifically on that developer kind of ecosystem and timeline, which is new. They hadn't done this before. They'd kind of done IT stuff. They do like crypto certifications and crypto stuff, but they hadn't really kind of honed in on like software development. Now they have something called the SSDF, which is the Secure Software Development Framework, which is kind of like the NIST cyber framework, if you're familiar with that, but targeted just at software. The problem was it's not really actionable. It's a little bit kind of lofty, like, wishy-washy goals, like, be secure, right? Great. That tells me nothing. But I'll try. If you try hard and believe in yourself, you too can have a secure application. So anyway, they came out with this thing called the minimum standards, and I like it. It hits the Goldilocks zone. And what I like most about it is that, maybe not in most, I'll just say in addition, it hits the Goldilocks zone. Its advice is actionable. It's not over-specific, and it's vendor neutral, right? And so that's important because if you are not in a security-minded organization, cost is a concern. And you're going to show up and start proposing lots of tools, and they're going to want to know, like, who says I should do this? You? I'm like, well, yeah, you paid me to give you advice, right? But no, they want a second opinion, right? Suddenly everyone else's opinion matters very, very much, whether they know what they're talking about or not. And so having NIST, which sometimes the IT folks are used to from this 800-171 compliance thing, give the thumbs up on like a NIST recommendation can help you build consensus towards acquiring tools and building out an AppSec program. Because, hey, it's a NIST recommendation, and they know what they're talking about. And in this case, I think they do, right? This represents kind of a good enough standard. So where does this come from? Well, there was an executive order. So, government cyber posture sucks. So the president's got to issue orders. Thou shalt be cyber hard. One of those orders was Executive Order 14028. And it said, hey, NIST, you've got 60 days to produce recommendations for software development. And they did. They hit that timeline. So this order came out in May. I think by end of July, they had it published. Was right when I was trying to kind of come up with a framework to use. I saw this come in my inbox, and I read it, and I was like, perfect. I've just done my own research. I've come to almost the same conclusions, except this is in a prettier document, right? Great. I'll steal that. And that's kind of the genesis of this talk, was this is new. It's within the last year. If you haven't heard about it, I just want you to know about it. You don't even have to remember anything about this talk. Just know that this exists, so you can go Google it later when it comes up, right? Know how to find the information. So what are the minimum standards? This is them. There are only 12 of them, not 100 plus, just 12. This is a reasonable sized list. It's not too big. It's not overly prescriptive. And you'll notice they're not saying use this tool over that tool, because that all depends on your ecosystem and your language. It's actionable, but it is a minimum recommendation. Now this is the weird part, right? If you read the document, they hit this a couple times. This is the minimum recommendation. This is the minimum recommendation. The expectation is that all developers are doing this. They're not. They're not, right? So if this is the minimum, we're in a really bad place. I'll talk about later how you can, basically, if you're familiar with the Joel test, I'll talk about this later, but the Joel test is from the Joel Spolsky's blog from about 20 years ago, where he said, hey, what's a good developer ecosystem look like? Here are 10 things you should look for. Ask the developers in your interview if they do one of these 10 things, give them a point for each of them, and then, do they pass? Are they above 5? Are they above 7? Or did they hit all 10? That's a Joel test. I like the concept of a Joel test being like something that's easy to evaluate, something that can be done relatively quickly, doesn't require any kind of deep dive. This is kind of like a Joel test for application security. So as a consultant, I can jump into an ecosystem and I can just quiz people. Say, well, do you do these things? Yes or no? And then I've got the authoritative NIST source to say, that's the minimum. You don't need the minimum. Let me help you reach, fix the deltas, basically. Or you go fix the deltas. Or at least here's what the deltas are. So for a couple reasons, I like this NIST standard. So let's talk about what each of these things are, because you may not be familiar with all of them, and that's fine. I'll teach you. So threat modeling. So threat modeling is just thinking like an attacker, right? Don't just build the thing. Think about how you could attack or break the thing. Then once you identify those weak points, you can actually design around them, right? You can make different decisions. This is kind of like a pre-mortem. You've heard of a post-mortem. That's this thing broke. Now I've got to figure out the root cause so I can fix it. This is a pre-mortem. I haven't built it yet. How might it break? Can I do something differently? This helps fix design and logic flaws, right? A lot of the other security tools can find vulnerabilities kind of based on pattern matching, known things, bad library here, bad operation there, but they don't help fix logic flaws. It doesn't catch, you didn't actually check authentication, right? this is the kind of thing that your software is technically correct while not actually achieving the desired end state. And so thinking through these kind of problems is what you do when you do threat modeling. Now, if you've done threat modeling in the past, you might be like groaning internally right now because you're like, I don't want to have a big diagram full of wires and blocks. I don't want to have to figure out all the inputs and outputs. And oh, by the way, this thing's been under development for 5 years and nobody understands it, right? So for a lot of reasons, old school threat modeling is kind of painful and slow. And so I'm going to recommend something different. And that's called the Threat Modeling Manifesto. So in the same way that the Agile Manifesto came out, a couple of people who thought they knew what they were talking about got drunk at a ski resort, and they came up with a list of things that the rest of us were supposed to do. Same story here, but with threat modeling. A couple of security researchers having some drinks after a con thought, why does threat modeling suck, and how can we make it better? And they came up with this lightweight approach. And this is it. No diagrams, just 4 questions. What are we building? Because sometimes even that's not clear. What could go wrong with the thing that we're building? Then once we've identified what could go wrong, what are we going to do about it? Choose if you're doing if you're doing a mitigation, if you're doing a redesign, if you're going to ignore it, if you're going to carry that risk, whatever. Figure out what you're going to do, and then reevaluate. Did you do a good enough job? Based on what you're building, what could go wrong, what you're planning to do about it. Is that good enough? So there's the URL for Threat Modeling Manifesto. And what I like about this is it's so lightweight. You don't have to go back in the past and kind of dig up your design documents. You just start doing it today. Somebody says, I've got a new ticket to add a new feature, and you say, great, let's threat model that feature for right now. You can even put this into your ticketing flow if you're using like a build tool like Jira or something like that. You can make it a requirement. Hey, fill out this block with these things. And then I like this because as a consultant, I'm usually outnumbered. There's usually one security person on a team of dozens or hundreds of developers, and I'm supposed to fix it all. So if I make people put their thoughts somewhere in a consistent place, I can go look at that, and I can evaluate that, and I can help train people, because that's really kind of the name of the game, is kind of raising up everybody else's ability, to do the AppSecs, if you will, because you can't by yourself. So just start wherever you are in your architecture. Just start doing this stuff. So the first complaint is you say, hey, Mr. Developer, Mrs. Developer, please threat model, and they say, but I'm not an attacker. I'm not a hacker. I don't know how to do this kind of stuff. And so you say, great, I've got a cheat sheet for you. So, this eliminates an excuse. This is called Stride. This comes from like the 2000s Microsoft, oh no, things are bad era. They came up with this internal mnemonic to help think through the different possible attack vectors. It's not comprehensive, but again, remember, it's reasonable. It's got a URL to a Wikipedia site. I can email to people. This is the repeated touch and the consistent, concise language is really important to kind of like get people as a group to do a thing. And, you want to be high speed and really super technical, but like the group's not ready to keep up with you at that pace. So Stride. Stride's how you say, here's how you think like an attacker. Here's your 5-minute training. Stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And if you don't know what any of those things are, I would say go to that URL and read for yourself. So it's just a way to get people to think like an attacker. All right, so the next bullet on the NIST minimums is automated testing. Tests should be quick. Tests should be easy. Tests should be automated, because if they're not, they won't get run. So inside any developer ecosystem, they're probably using a handful of tools, and they may or may not be using automated testing in those tools. You need to enforce that, right? Having tests is not good enough. Let me make that distinction clear. Having tests is not good enough. You must run the tests, and the tests must be run automatically, right? And that means they need to be triggered at some point. And this is up for debate how you trigger it. It kind of depends on your maturity. There are like full CI/CD shops that are triggering on every commit. That's great, because you can just do like scans on the deltas, and then it can be fast, and blah, 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 blah. It takes a lot of work to get there, but it's awesome when you get there. But if you're not there, that's okay too. Just start doing them on your nightlies, right? You're doing nightlies, right? Like your nightly builds, your weekly builds, your monthly builds, some cadence besides we deploy tomorrow, start running your tests. And if you can trigger them automatically, then you can kind of, this is how you like ninja your way out of a problem, right? You sneak into the code base, you set up a trigger to run the tests, you don't tell anybody, and you just back out. And then when the developers commit something and it breaks, right, then you can say, aha, well, that's because you didn't fix this thing, right? You've actually prevented badness from ending up in the deployed application. So if you don't have a test for it, you're not going to get it. Write the tests and run the tests. It's also okay to split your tests up into groups. Right? There's no kind of like wrong way to eat a Reese's, right? There's kind of like no wrong way to build out an AppSec program, if you're shooting for the same goals. So you don't have to have one giant test suite that takes 12 hours to run. You can split that up into the ones that take a little bit of time and the one that takes a long amount of time. Run the ones that take a little bit of time a lot. Run the ones that take a long amount of time less often, right? This is fine. This is okay. There's no wrong way to do it. Just do it. Number 3, static code scanning. So if you've not heard of the buzzword SAST, this is SAST. SAST stands for Static Analysis Security Testing. Now, SAST is actually a whole category of things, but in practice, it just means source code scanning. But really, so the static part of that is it's not running. Your application is not live. It's dead. It's a file on disk. You're going to scan that. And the benefit here is 10, 20 years ago, we were saying, hey, developers need to get security training. Go get certificates to learn how to write code securely. Okay, so they go to the training, they sleep through it, they pass the test anyway, but then they don't actually implement anything in practice because people are just bad at the details. Humans are bad at details. So what's a SAST scanner do? Well, somebody wrote some software that says, well, let the software know how to code securely and let the software enforce it. That's a much better use of everyone's time. Software is good at details. So we encode the details into a rule set, and that rule set gets run by a SAST scanner, and then it can kind of do code review for you. Your code review should focus on like meeting requirements and like general architectural things, not on like the nitty-gritty details, not if they don't matter. So this is a way to kind of like unload the plate of our developers, but also provide that safety net. There's different standards and products. Doesn't matter. Pick one. Anything's better than nothing. And if you remember 3 slides ago, I said, hey, threat modeling catches logic flaws that your SAST code scanner won't. Right here is that bullet again. Hey, it's not going to catch every flaw. It's not a panacea, but it catches a lot of the well-defined, the low-hanging fruit, if you will. Again, that makes it easier for you to focus on the harder edge cases. And then it also only provides value if you fix the findings, right? So what good's a bug report if you never squash the bug? What good is a vulnerability scanner if you never actually fix the vulnerabilities? Kind of like having tests is necessary but not sufficient. You must run the tests. Finding errors is necessary but not sufficient. You must also fix the errors. So please just grab the closest SAST tool you can and use it. What kinds of things might it find, you might ask? Things like the OWASP top 10. So OWASP, and again, what do I like about top 10? I can email this to somebody. I don't have to email them the document, like the CVE list, if you're familiar with that. I don't have to email them the OWASP application security verification standard. I'm not asking them to read a 300-page document. I'm not asking them to learn a whole new lexicon. I've just got 10 bullet points. And I say, hey, these things are bad. Let's make sure we don't do these things. For people who have no exposure, this is a good first exposure from a relatively trustworthy and legitimate source for them to go learn a little bit more about security. And your SAST scanner can find these kinds of things, right? Wouldn't you want to take away the top 10 most vulnerable things out of your application? Of course you would. So use a scanner to do that. Number 4, secrets scanning. So this one is similar. It's a scanner, right? But it's going to find secrets. And so what are secrets? Those are your credentials, your API keys, your passwords, all the stuff that kind of manages authentication and identities, really sensitive stuff, the kind of stuff you don't want to end up on your public GitHub, right? And so what a secret scanner does is it says, hey, I know what API keys look like. These are standardized. I know what web tokens look like. I know what passwords look like. I know that crypto certificates have a certain amount of entropy. They don't look like text. I can identify these things for you. And that's precisely what a secret scanner does. It says, I'm going to find the secrets, and I'm going to call them out to you so that I can stop you from putting them in your code base, right? Get them out of the code base, get them into some type of secrets management engine or configuration thing. Again, that's up to debate. That's up to you and your ecosystem, but get them out of the source code, definitely. So you don't want them to leak, right? If you get them in the code, they're hard to change. People forget about them. And so that's what a secret scanner does. Because if somebody gets on your public GitHub, and so hey, surprise, you're not all developers, I appreciate that. GitHub stores your source code, right? And it stores the history of your source code. So if you put a secret in and then you went, oh no, I'll back it out. The history is still there with your credentials, right? Even though it's no longer visible, anybody who knows what they're doing and knows how to look for it will go find it, and I will try it, and it probably still works, right? And now I'm in your system. So it's very critical not to even let the secrets get in the system. Use a secret scanner. Get the secrets out. Next one, this is a big one. Built-in checks and protections. So I am primarily focused on like embedded applications, where people are still using C and C++, non-memory managed things. That's fine. The problem is those communities are heavily invested in backwards compatibility, which means whatever new feature I add, I will not enable it by default because you might not be expecting to use it, and that would break your build. So lots of progress has happened in the last 20 years, adding security to these languages, but it's not turned on by default. And also your developers, they're interested in reading about design patterns, right? And like factory functor, blah, 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 blah. They don't read about ASLR though, right? Address space layout randomization, which is a cool tool that you can just pretty much enable with a compiler flag, right? So again, depending on your language, depending on your runtime, there's probably some security features. You should make sure that those are turned on. This is free security. Again, for like C, we're talking stack protection, control flow integrity, address space randomization, non-executable regions. All these things exist because they had to in the cat and mouse game of security. We had a mitigation, there's a bypass. So we made a new thing and there's a bypass. There's another thing and there's a bypass. And so staying at the edge is not helpful because all those other bypasses and security problems still exist. So you've got to kind of do all this stuff. But if you don't know about it, you don't know about it. The great thing about this, though, is, again, we can be AppSec ninjas. We can sneak into the build system. We can add these flags to the compile line, and we can back out. And no one even has to know that we've improved the security. It's like that Futurama meme when Bender's talking to God, and he's like, if you're doing AppSec right, they might not even know you're doing anything at all, right? And that's great, because you've achieved your end state without kind of ruffling any feathers. All right, so number 6. So we talked about doing tests, but what kind of tests should you do? Well, one of them is functional testing. Functional testing basically means, does this thing meet requirements? Does it meet specs? Does it do the thing I actually expected it to do, right? This seems trivial, but people still don't do it, right? A lot of people default to just like ad hoc user testing. Hey, try this thing out. Does it work? Yeah, it seems to work. But the amount of coverage that a person can do is just so small compared to any kind of legitimate test suite. So functional testing is to focus on those kind of functionality things at the input-output boundaries. And so I've bolded something here that's super important, and that's negative test cases. Everyone writes a test to demonstrate that the thing behaves the way it's supposed to behave. Nobody writes the test that verifies it fails well, right? Or that it doesn't bug out when you put in nonsense values, which happen in the real world. So negative test cases are super important. I would say, if I'm doing a code-based review, if I'm doing a test review, I expect at a minimum to see like one positive test case and one negative test case. It's necessary, but not sufficient, right? It doesn't give you full code coverage, but it's a decent place to start. Negative tests, they're important. Then we've got structural tests, right? So where the previous one was about, hey, does this thing function the way you thought it could and should and would? Structural testing is more about the implementation, and your implementation will vary, right? So like a Java application on a JVM has different runtime problems than a C++ application does, right? That's just running bare metal. And so depending on your implementation, you might want to do different stressing cases, resource exhaustion and different permissions and timing constraints and race conditions. These are all things that don't show up when you're just doing your input-output, does it behave the way it's supposed to behave testing. This is more of a stress testing of the actual implementation. And I can't give you specific details because this totally depends on your language and your environment and all that good stuff. But as a concept, go ahead and do some structural testing to stress the actual implementation. Next up, we've got historical testing. This is also called regression testing. And mostly this is done for bug fixes. And so what usually happens is somebody gets a bug fix, they hand jam on the command line, what they think caused the bug, that they are able to cause the bug. Then they vaguely dance around the code base using print statements and changing things kind of willy-nilly until that you can no longer evoke the bug and they go, ha-ha, it's fixed, and they commit that patch. And then what happens is you and I are working in parallel because we're using Git or something, right? And I've got a version of the code base, and you've got a version of the code base. And so you fix a code, and you commit your change, and then I commit some other code, but now there's a conflict, and so I overwrite your changes, and boop, we're right back in the same boat where we were, right? Now we've got the same bug back in action, even though we already fixed it once. So the right way you should approach bug fixes is to, first, you've got to be able to reproduce the bug. And once you can reproduce the bug, then you can write a test case for it, right? And the test case should fail because the bug is still present. Now we're kind of doing like test-driven development, but just for bugs. Now you can fix the bug, and when the test case passes, you actually know definitively that, hey, I fixed that thing, or at least the way that particular thing manifests in that way. And then you run the test to verify that it fixed. Great, but you save the test. This is the critical part. You save the test. The test should now become part of your test suite, right? And now you can run it again. And again, like, hey, it doesn't have to run every night, but run it weekly, right? Run it monthly. Run it on some regular cadence that'll help you identify like, when bugs have come back, because surprisingly, they do. It happens more often than you think. Next, we've got fuzzing. This is my favorite. This is my favorite tool. Again, I kind of come from a vulnerability research background where I love my fuzzers, but developers are not familiar with this, right? This is kind of it's not one of the basic tools. You know, people are like, I've got my favorite editor and my favorite compiler, and I got my favorite terminal and my favorite color scheme and my shortcut keys, but nobody has their favorite fuzzer, right? Nobody has their favorite fuzzer harness. It's just not part of their mind space. So the way fuzzing exists, so quick history lesson, hey, you know, computers are a thing, putting them, networking together over the phone lines, that's a thing. Turns out phone lines can be noisy at times, and if you and I are trying to write a chat app and lightning strikes and noise happens on the line, I corrupt your application, or my application gets corrupted. And then some smart professor goes, wonder why that happened. Maybe that could be a cool testing thing. Let me just write garbage into the line to begin with. And that's fuzzing. Fuzzing 1.0. It's really like random input into the application, and because nobody did negative testing, it just starts breaking all over the place. All the weird edge cases and boundaries start happening. It's a way to kind of like buy yourself into like free code coverage, if you will, because it can just run millions and millions of inputs where you're gonna write like, you know, less than a dozen unit test cases, really. And so fuzzers are really cool, but they've gotten way, way smarter than that dumb random input case. Now they're doing what's called instrumenting a code base, which means like adding hooks into the code base to actually tell like when I've gone down a certain path versus another path. And then my mutator can say, hey, I've been down this path before, nothing happened, let me try the other path because I'm tracing how the program is executing. Let me try some new inputs until I get to the other path. And so it's you know, maybe if you've touched fuzzers before and you thought, oh, they're a kind of a shallow testing tool, the state of the art has moved, right? And they're starting to kind of get deeper and deeper. And if you want to read more about that, just Google the DARPA code Cyber Grand Challenge, DARPA Cyber Grand Challenge. So that's kind of just a cool area of research. So use a fuzzer. It's like free testing, and it finds stuff. API scanning. Now, I took a liberty with this one because NIST actually calls it web app scanners. But again, that's very web-focused. We're not all building web stuff. And just because I'm not building a web thing doesn't mean that I'm not networked, right? So really, instead of focusing on the web, focus on like the outer boundary of your application, the API, the interfaces. You've done unit testing, you've done structural testing, you've done some interior testing, but also don't forget to test, you know, like the outer candy shell, right? Find all the inputs and outputs, find your API boundaries, and test at that level. Now, if you're using something well-defined, you know, like REST or SOAP or SQL or like whatever, right? So you imported some library to give you that API, then there's probably a scanner for it. And you just got to Google for it and use that thing. If you're doing something totally custom, you're on your own. You should still do this, test at the boundary, but you know, if you define a new thing, you're gonna have to find the new tool to go with the new thing. This is also DAST, Dynamic Application Security Testing. It means testing your application when it's running, when it's live. It's dynamic. It's the complement to SAST. Dependency scanning. Okay, so you write some software. You don't want to have to rewrite every piece of software that's already existed, so you import some libraries, right? This software is built. It's composed of things that you wrote and things that I wrote. And so the problem is a vulnerability could be in either of those pieces, the pieces I wrote or the pieces you wrote. And so we've now kind of built out an AppSec program where I'm testing my own stuff, but if I don't test your things too, and the other things that I import into my application, then I'm also just as vulnerable out on the web, even though it's not my fault, right? But it is if you're taking kind of a holistic approach to reaching some end state, right? So to scan your dependencies. And there's a couple tools that you can use for this. If you are using kind of a well-trodden build tool, your build tool can probably produce an output that is your list of dependencies, right? Or you can scrape them out of the log from your build just to know what's going in your thing. So many people, like Log4j is a great example. Okay, if a year and a half ago, Log4j popped, hey, 0 day in this thing. Where is this thing? Turns out it's everywhere, right? And so anybody who was running any system got the email, hey, are we vulnerable? Do we use Log4j? And you're like, oh, gee, well, we don't use Java, so probably not. No, surprise, it's in there somewhere, right? So in order to answer those questions, if you knew what the dependencies were all along because you built it into your build process, answering that email of is this thing in our software is a trivial question, right? It's a grep. It's a search on a log file. Is this thing in there? Yes or no. And then once you know what your dependencies are, you can put those into a dependency management engine or a vulnerability management engine that continually checks to see if any of these things are vulnerable. But you got to know what your dependencies are first. 12, squash the bugs, right? Having tests is not enough. You have to run the tests. Okay, knowing what the bugs are is not enough. You've got to squash the bugs. It's kind of enlightening that NIST felt the need to call this out, right? That bugs need to actually be fixed. And again, what I like about NIST is it's authoritative, and I can put that in front of a non-tech person and say, look how important this activity is. I know it's not adding new features. I know you feel like it's slowing development down, but it's so critical, it's considered a minimum thing that we just have to do. How can you look at anybody with a straight face and say we're doing a good job if you're not even doing the minimums? So I like that they put it in there, because otherwise, hey, it gets missed. So how do you squash bugs? What order do you squash bugs in? Well, if they're known vulnerabilities, they're gonna have a score associated with them, and then it's pretty obvious, right? You do things from most severe to least severe. It's kind of obvious. And if there's not a score associated with them, like let's say it's something in your code base, so no one's scored it before, you can just kind of assess your own score. So if you've ever done like risk management, there's like the two-dimensional matrix, right, of like risk versus likelihood. This is a really super easy, lightweight tool. Just associate what's the risk of this thing and what's the likelihood of this thing. Now you have a score. Now you can use that score to prioritize what you're going to do. So it doesn't matter what the method is, but please squash bugs, from most severe to least severe. So that takes us to the end of the NIST minimum standards. Here they are again. Take your picture of this slide deck, right? This is what we've just talked about, in broad senses, not in specific tool senses. And again, this is the minimum, right? So if you're in a developer ecosystem, if you work with software devs, if you're buying software, look at this list and just mentally go down the list and see how many of those things do you do versus how many things do you not do. Another thing to call out is that this is not the totality of application security, right? We're not talking about like the current hot topic is software supply chains. So if development is an activity that's happening right now, software supply chains are a left activity. This doesn't cover that. And deployment and runtime monitoring, that's a right activity. And this doesn't cover that either, right? Back to scoping, application security, is kind of a development activity, but it's not comprehensive for your whole life cycle. So don't use it where it should not be used. So now you know what this is. Great. So what should you do with this information? Now that kind of have this framework and you know some of these words, what do you do next? And that largely depends on what your role is in your organization. So if you are the requester of software, if you're a person who acquires software, writes requirements, gets things to do things, make sure that you put this in your contract language. Make this a requirement. Again, you don't have to know how these tools work, because that's not your job. You just have to make the request. Back to that GAO report. If you don't ask for it, you won't get it. So ask for it. Now you know where this thing is, and you can put it right in there. We require that you meet the NIST minimum developer standards for software, blah, 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 blah. Just get it in there. And then that's if you're having something developed custom. If you're just pulling stuff off the shelf, if you're just evaluating various things, most people are pretty much solely focused on like value. Like what's the price? Does it do what I need it to do? What's the price? Okay, that's a factor. I'm suggesting you just add another factor, right? Add another factor, and that factor could be, or should be, how application secure is this thing that I'm about to put on my network and make edge facing, right? Just think about that, because instead of spending money doing like disaster cleanup, you could have just spent a little more money to buy the tool that would have prevented, or delayed a disaster to begin with. So add that to your toolbox as you're thinking. So this is for people who are requesting software. Now, they're only one part of the problem, though, right? We also have our developers who are not trained. And so they're going to get this requirement that says, thou shalt do this minimum standard thing, and they're going to be like, oh no, I don't know any of these words or any of these processes. That's fine, because the NIST recommendation includes a nice little 30-page report, and 30 pages seems like a lot, and so you compare it to like the 300 pages reports that they make in other places. The 30-page report is actually pretty readable, right? I read it again last night. okay, to prepare for the talk. I read it again. So it's pretty readable, it's pretty digestible. I like it. It seems sufficient to me. It's like on parity with the kind of developer documentation that developers would already be familiar with, right? So if they're a developer who's good enough to develop our software, they should be able to read this document and understand what it's saying and take action on those things, right? And so, hey, Mr. Developer, go read that document so you know what you need, but then you've got to pick tools for your environment. And so my recommendation to you is that you pick tools that work well together. Good example is dependency management. So get a tool that tells you what your dependencies are, but make sure that it provides output that allows you to then inject those dependencies into some vulnerability tracking engine. So now we're kind of moving a little bit left into the pre-development stuff, and this is a new buzzword for you, software bill of materials, SBOM. An SBOM is just a defined format that lists all your dependencies. But if you get a tool that produces the SBOM that's the same format as a vulnerability tracking tool that ingests an SBOM, now you have two tools that work together, and that's one less thing for you to develop, right? Now, I don't have to write a conversion utility that I also have to manage. So pick tools that work together, and then start adding them from left to right. So kind of feedback loops are the name of the game, right? I don't want to spend, imagine a developer build cycle that takes 12 hours. I don't want to find out at hour 12 that I had an issue that I could have found in minute 1, right? Because now we're talking like days of people's time now. I start a build and I go home and I come back the next day and it's broken, and I don't know why. Well, it might have broken as soon as you walked out the door, right? So we want to front load things, shift them to the left to the soonest point that we can find them in kind of the iteration cycle. So work things from left to right as you're kind of adding them into your process, and then also start in easy mode and then ratchet things up over time. Common problem is people put tools in, they say, well, of course I want us to find all the vulnerabilities. Tell the tool to find all the vulnerabilities. Great. Now you have a report that's too long to read, right? And because it's too long to read, it's easy to compartmentalize and say, yeah, not doing that, and it doesn't get done. So my suggestion to you is to ratchet the level down, right? Say, show me only the most vulnerable problems in my software. You want the least actionable amount of information. It doesn't make the rest of the things go away, but you get to them later, right? So put the tools in, scope the severity levels such that you only see the most severe things, fix those, let everybody kind of calm down, right? Let the inflammation go away. Then you can sneak back in AppSec Ninja style and turn it up a notch, right? And start fixing those things. And then finally, we've got the evaluators of software and build systems and stuff like that. So how do I evaluate an AppSec program? You know, how do I improve my AppSec program? Maybe I don't have a requirement, but this is just a thing I want to do. It's really easy. This is the Joel test that I was talking about. So hey, you just go to your developer team and you say, for each of these processes, for each of these recommendations, do we do that? Right? And can you name the tool that we're using to do that, or name the process that we're using to do that? If they can't name a tool that you can Google and find a web page for, or a blog or something, like they're probably making it up, right? Anybody who's like, oh, we're so good, we have internal processes, blah, 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 they're living in fantasy land, right? If their internal processes are so good, there should be no problem with adding defense in depth kind of secondary tool to verify how good their software is. So ask them to show you the output of each tool, right? Because again, having the tools is not enough. You got to run the tools. So first have the tools, then run the tools, then show me that stuff, and then you can give them points, right? NIST says 12 recommendations minimum. So hey, 12 points is the minimum. Anything below that's failure. And now whatever you're failing on, you can go either request or fix or work on. So I really like this test. This is personally helpful to me as a consultant who gets dropped kind of in a place. It gives me a jumping off point, right? I can give a presentation very much like this, and we can do the test, and then we can start talking about what's the right tools and what's the right implementation strategy. I like that a lot. And so there you have it. That is what makes a minimum viable AppSec program from a relatively vendor-neutral but authoritative source. Some recommendations for how to apply it, how it's valuable to you, how you might use it. And of course, there's my email. If you want a copy of these slides, I'm happy to send them to you. You can also send me your questions. You can also send me your resumes, because we're hiring. Yeah, I'm happy to engage with all of you in that way. And we got just a couple minutes left. Does anyone have any questions about things? Yes, sir. My favorite fuzzing tool. So I like AFL, right? So AFL stands for American Fuzzy Lop, which is a type of rabbit. Not important, but it was one of the first tools that kind of started to do instrumentation and in a way that allowed fuzzing to kind of get a little bit deeper into the code base. It's relatively easy to run. It's also got some cool flags, and it's got some hookups to like virtual machines. So even if you have no source code, you can do some fuzzing instrumented that way. So that's kind of neat. I like that. Although I did just get approval at one of my client sites to start using For All Secure's Mayhem, which that's a company that won, Google this, the Cyber Grand Challenge, the DARPA Cyber Grand Challenge. The research group that won that competition created this program, and now I'm going to get a chance to play with it. But it's super expensive, so I've never touched it before, so I'm kind of excited. Any more questions? Yes?
So you said you sometimes work with like hundreds of developers. Is there any common variables with the people you go to consult in terms of like leadership buy-in to say we need an AppSec consultant? Is there like a common variable with that?
I wouldn't say that there's a common variable, but I would say it's kind of very bifurcated, right? You've got people who, they've called you in because they know they have a problem and they're ready to take your recommendations, right? And then you can kind of just, build consensus and make sure that you're demonstrating value and all that kind of stuff. And then you've got other people who don't know they have a problem yet. And that's when you go a little bit AppSec ninja, right? And you kind of turn into like a red teamer a little bit, where you're like, let me show you where the problems are. Because at first I've got to demonstrate, it's like, before you can solve a problem, you have a problem, get your poker chip or whatever, right? Do the red team kind of assessment, demonstrate that there's a problem, then you can bring the proposed solutions, right? And start having that kind of conversation. So I don't know that it's common, universally, but there's kind of these two camps of people. They know they have a problem or they don't know they have a problem. Does that answer your question?
But yeah, I was just wondering like who usually are the people who decide we need something from AppSec, like who gets the support,
Yeah. Also, could be either way. So example, like GAO report comes out that says, hey, government people who buy software, you need cybersecurity. So now that's kind of a top-down thing where people are like, I don't know what I don't know, and I don't know how to ask for it, but get me an AppSec person, right? Poof, and they define an AppSec person. So that's one approach. But then there's the other approach where it's developer-led, and then that's just like cultural, kind of on a company-by-company basis, where like if enough developers say, hey, this is an issue. And of course, developers are smart, right? They just have to choose where they put their focus, right? So in a lot of those times, developers solve the problems themselves because they find the same resources that I find, right? So they don't need me if they're kind of self-starters in that way. Any more questions? Awesome. Thank you for coming. Send me an email. I'll send you a copy of the slides. Have a great con, everybody.